3, 2, 1.
Hello! Today, we'd like to teach you how to solve linear systems. And today we're going to use something called Cramer's rule. So our objective for today is that you'll learn how to solve systems of linear equations in two variables by matrices in something called Cramer's rule. Here's the academic standard. Solve systems of 2 or 3 linear equations in 2 or 3 variables algebraically and using technology. Recall that a system of linear equations in 2 variables consists of 2 equations that can be written in the following form. ax plus by equals c, and dx plus ey equals f. Notice that both equations use the variables x and y, and they're in standard form. You've done this in Algebra 1, because remember that you can solve a system of linear equations in multiple ways. You can graph them and find the point where the 2 lines intersect at. You can do substitution, you can do elimination, and today we teach you how to do them by something known as matrices. So to begin with, let's define a matrix. A matrix is a rectangular array of numbers. It has m rows and n columns. The plural of matrix is matrices. A matrix with the same number of rows and columns is called square. We'll use those today. 2 matrices are equal if they have the same number of rows and the same number of columns and have the corresponding entries in every position are equal. Everything in the matrix, all the numbers are called elements, and you define where an element is by the row that it's in and the column that it's in. So, for example, row 3, column 2, the entry is 3. So, what we're going to do today is we're going to use a matrix and something about a matrix called a determinant. Determinants are only found with square matrices. Every square matrix can be associated with a real number that's called its determinant. In a 2 by 2, the way you find the determinant of a 2 by 2 matrix is simply take this difference of the cross products. So, what's in row 1, column 1 times row 2, column 2 minus row 2, column 1 minus row 1, column 2. Look at the examples. That's a little easier to see. Here's our matrix. Row 1 is 2, negative 3. Row 2 is 1 and 2. So its determinant would be 2 times 2 minus 1 times negative 3. 2 times 2 is 4. The 2 negatives make that a positive 3. 4 plus 3 is 7. Take a look at this matrix. 2, 1 are the row 1 entries. 4, 2, so 2 times 2 minus 4 times 1, or 0. 4 minus 4 would be 0. Here, well, you can go back and we'll show you this one too. So again, to define the determinant, and we can only do this with square matrices, we cross multiply. 4 times 5 minus negative 3 times 6. Minus minus becomes a plus, and the determinant of this 2 by 2 matrix is 38. So a gentleman by the name of Gaussian and Cramer discovered a way to use matrices to help us solve systems of linear equations. And he liked it so well, we call it Cramer's rule. So take a look at our 2 by 2 system. Notice that the bottom determinant is the coefficients. A and B are the coefficients of the top equation. They're in row 1. C and D are the coefficients of the bottom equation. They're in row 2. Also, notice how the coefficients line up. The coefficients of x are in one column. The coefficients of y are in a second. At the top, notice that we've replaced the coefficients of x. We've replaced a and c with the solutions to our equations, m and n. We'll use that when we find x. In the second, notice that we've replaced the second column. Where the y coefficients used to be, we replaced those by the answers. Let me show you an example and make it a little easier. Solve the system 8x plus 5y equals 2 and 2x minus 4y equals negative 10. So what we want to do first is we want to find the coefficient matrix, the matrix with just the coefficients. So 8 and 5 become our first row, the coefficients of the top equation. 2, negative 4, the coefficients of the bottom equation. Again, notice the x's are in one column, the y's are in the other. So the determinant of that coefficient matrix, 8 times negative 4 is negative 32, 2 times 5 is 10, so the coefficient matrix determinant is negative 42. Now, we want to find x, so we're going to replace the column of x's with the answers. So notice instead of 8 and 2, 2 and negative 10 are in their place. And then we find the determinant of the top matrix. 2 times negative 4 minus 10 times 5. That's negative 8 plus 50 because you have a negative negative. That becomes 42. We then divide it by the coefficient determinant, which was negative 42. And thus we'll get x equals negative 1. For the y's, notice that now we replace the column of y coefficients. So 5 and negative 4 get replaced by 2 and negative 10. Notice that 8 and 2, the x coefficients are back in the column where they originally were. So we find its determinant, 8 times negative 10 minus 2 times 2. Negative 80 minus 4, which is negative 84. Divide that by 42. And thus our answer for this system becomes negative 1, 2. Let's look at a second example. Here's our system, x minus y equals 4, and 2x plus y equals 2. So again, we take our coefficients and make a matrix. 1 and 2 are the x coefficients, that's the first column. Negative 1 and 1 are the y coefficients. Again, notice the equations match up. 1 and negative 1 are the coefficients of the top equation. 2 and 1 are the coefficients of the bottom. So now we'll define the determinant. 1 times 1 is 1. 2 times negative 1 is negative 2. This determinant is 3. We'll find the determinant for x. So the 4 and the 2 go in where the 1 and 2 are. We're trying to find x, so we got to replace the x coefficients. 4 times 1 is 4. 2 times negative 1 is negative 2, and 4 minus negative 2 is 6. We then take 6 divided by the coefficient matrix determinant of 3, and we find out that the x to this solution is 2. We then do the same thing. Now we want to find the determinant of the y's. So x is back in the first column. 4, 2 goes into the second column. 1 times 2 is 2. 2 times 4 is 8. 2 minus 8 is negative 6. Negative 6 divided by 3, the y is negative 2. That's how you do Cramer's rule in solving 2 by 2 matrices.